Okay, now as promised, I want to talk real quickly about linear equations. Now, linear algebra is a whole field of study, and we're going to get into that in more detail in a little bit. But for right now, I want to talk to you a little bit about formatting, basically how you get problems like this into MATLAB. Now, these are just two little simple linear equations. If you plot them, you get two straight lines. And to solve this system, this little tiny system, what you're doing is you're finding an x and a y value that makes both of these equations true. Graphically, it's where do they cross on the axes. It's very simple. Well, before we do that, let's solve this analytically. Let's solve it by hand. Now, there's a bunch of ways to do this. The easiest one right here is to say, well, if these two things both equal y, they must equal each other. Let me write that out. I'll do it in blue here. Okay, if they both equal y, they must equal each other, which means I should be able to do that. Now, this is basically substitutions, what's going on here. Well, let's see, one equation, one unknown. This doesn't seem that hard. So let's push all the x's to one side, and let's push all the numbers to the other side of the equal sign. So let's see, it looks like 3x must equal 6, if I got that right. Yes? So x must, I'm checking on my screen down here to make sure I got this right. I'm going to feel stupid if I make a mistake. So x equals 2. Well, if x equals 2, what's y? Well, 2x minus 2, so y must equal 2 as well. All right? So simple. This is so easy a professor could do it. I need to write bigger, I think. Now, the nice part about how MATLAB and other software handles these equations is it does it in a more general way. So general, in fact, I don't care what size of equations I'm working with. This is a second order system, or what we call a 2x2 system, really. So there's two variables and two equations. It's very typical for computers to work with much, much larger systems than that. Millions is routine. And the way that works has to, at this point anyway, has to do with notation. So we got the right answer here. This problem wouldn't have to get very big until you just couldn't do it by hand anymore. So we have MATLAB. Remember, MATLAB originally stood for Matrix Laboratory. So you can see we're headed for matrices here. I'm going to make a couple of formatting changes here, and then I'm going to show you how that formatting change lets you solve these equations easily in MATLAB. So what I'm going to do here is I'm going to put all the variables on one side of the equal sign and the numbers on the other. So I'm going to say, like, let's see, and the other thing, I've got to decide, do I want the x's to be positive, the y's to be positive? It doesn't really matter. I'm just going to subtract 2x from both sides here. I'm going to add x to both sides there. So minus 2x plus y equals minus 2, and x plus y equals 4. All right, that doesn't look like I really changed much. Mathematically, I didn't really change anything. It's just whip a little algebra on it. Now, I'm going to make one change here that I'm going to write out the coefficients in front of x and y, and I'm going to push x and y over to the side. So the coefficients in front of x is minus 2. There's a 1 there. It's implied. We don't write it, but there, that is 1 times y. 1 times x, 1 times y, and it equals that. So I'm going to write it out in this way. All right. Okay, this and this mean exactly the same thing. All I did was change the format. I just changed the way I wrote it down. And I did this for a very, very specific reason. Now, this matrix this is a matrix now. That's a vector, that's a vector. I'm going to be a little pedantic, perhaps. Matrices are going to have square brackets around them, and vectors are going to have these sort of curly braces around it, just to distinguish one from the other. So minus 2, 1, 1, 1. That's right there. Minus 2's there, 4's there. and x and y go to the side here. Now I was very careful to write x's in this column and y's in that column. It's extremely important that the x's all line up and the y's all line up so that x and y go there. Now the rules of matrix multiplication are that if I were to multiply this all out, I would get that. We're going to worry about matrix multiplication later. Right now I'm just trying to show you how to run this through MATLAB. Okay, so why am I doing this? This just seems like busy work, doesn't it? Well, there's a generalization going on here that's extremely powerful. This entity, this matrix, I'm going to give it a name. I'm just going to call it A. I'm going to call this X. And I'm going to call this B. Now X here just denotes, this is just a list of variables. I have to call them something, so I'm calling them X. You'll see this in all the books. And unfortunately, it looks kind of like I'm I'm using the same variable for two different things. That's not what's going on here. Well, all right. In fact, I'm even going to get rid of the braces here. Let me go back. Now let's see. Let's go over here. Don't need that anymore. If I had to solve AX equal B, how would I do that? Well, you divide through by A and, X equals the inverse of A times B. Now, for, I don't know, historical reasons, I guess, in matrix algebra, we don't write B over A. We write inverse of A times B. It means the same thing. And this is true no matter how big A and B are. It doesn't matter if this is a 2 by 2 matrix or a million by million matrix. This still works. That's a generalization, and that's powerful. So let's go over to MATLAB right now, and I'll just show you how to plug this in, and we'll solve it.